Hey, Matthew. So I was going over the problem that we were looking at yesterday, and we were totally doing it the right way. So I'm thinking I must have been making some kind of small error. I'm not exactly sure what I was doing or what that was. So I'm just going to run through it really quick, and hopefully it helps you. So we're looking for our population, which is the big N, and our population successes, which is a big R, and then our sample size and our sample successes. And so in this one, the urn contains 5 blue balls, 9 yellow balls. So that's 14 altogether, 9 plus 5. That'll be our big N. And then we're going to define successes as a blue ball. So that will be 5 successes in the population. And then we're going to select 5 balls. So we'll have a sample size of 5. And it's what's the probability that of the balls selected, 2 of them will be blue. So our X, or our sample successes, will be 2. So to find this out, the probability, we're going to do equals hype geom.dis for hypogeometric distribution. Our sample successes is 2, or is our X. Our number in the sample is N. Our population successes is R, big R, and our number in the population is big N. Since we're looking for the probability of a single, this single outcome, right, that 2 of the balls are blue, we're going to use false rather than a cumulative probability. So that gives us 0.4196. So you can see it worked fine. So I must have been making some small error yesterday when I was doing it and messed it up, maybe because I was in a hurry. So the second problem, or the last problem, number 12, it uses similar logic. So we can actually use our same calculator we have in place here. White boxer dogs have a genetic disposition for going deaf. Suppose a litter of 9 white boxer puppies contains 2 dogs that will eventually experience deafness. A family randomly selects 2 puppies from this litter to take home as family pets. So we don't know our X yet. We know our big N is, let's see, the litter has 9. Our successes, or dogs that will eventually go deaf, is 2. And then our sample size is 2, the number of dogs people are taking home. So it says determine the probability that none of the puppies, so we would just put in a 0 for X. We got 0.5833. So that's a decent probability that neither of the 2 puppies we get, or the family gets, will experience deafness. Determine the probability that one of the 2 puppies, so we'll do 1, 0.3889. Determine the probability that both puppies will have deafness, 0.0278. So that's pretty low. That's 2.8%. And then it wants us to calculate the mean and standard deviation. Unfortunately, there's no Excel function that will do this for us, so we're just going to have to use the formula. These are in the book on page 233. So the formula for the mean is just the little n, so the sample size, times the big R, which is the population successes, divided by the big N, or the number in the population. It wants 3 decimal places. So 0.444. Then the standard deviation, unfortunately, is a much bigger, more unwieldy sort of formula. But we can still work it out in Excel. We can just say this equals the square root of little n times big R. So little n times big R times big N minus big R. Whoops. Big N minus big R. Divided by n squared, or big N squared. So there's our formula for the first radical. And then it's going to be that times the square root of big N minus little n. Divided by big N minus 1. I put one too many parentheses in. It'll autocorrect for me. Thanks, Excel. 3 decimal places. 0.550. Let's see if I did that right. Nice work. All right, well, I hope that was helpful to you. Sorry again for the confusion yesterday, and good luck.